Welcome to today's class. In today's class, we'll study about covalent bond formations according to VB theory, valency bond theory. In our previous class, we have seen ionic bonds, bonds formed due to ions. One atom is having excess electrons, so it is losing electron, it attains positive charge. Other one is having less electrons, so it is receiving these electrons and obtaining negative charge. So positive is called cation, negative is called anion. These two combine and you get a bond called as ionic bond. And particularly in ionic bond is formed between dissimilar atoms. That is what NaCl, right? And next Na2O, KCl, K2O, CaCl2, CaO, MgCl2, MgO, AlCl3, all dissimilar, right? One is sodium, NaCl means sodium, other one is chlorine. So it is common for all the examples what I have told you. Now coming to covalent bond. This bond is formed between similar as well as dissimilar. Similar means what? Hydrogen, hydrogen combined to give you H2 molecule. Nitrogen, nitrogen combined to give you nitrogen molecule N2. Same way oxygen and oxygen combined to give you O2. Similarly, you will get hydrogen chloride also, HCl. Similarly, you will get hydrogen fluoride, HF. Similarly, you will also get hydrogen sulfide, which is H2S. What happened? First cases, all similar ones. Next time, what I am telling you right now is all dissimilar one. So, this is what the bond formation is. Now, we will see, and covalent bond is obtained due to sharing of electrons. So, when electrons get shared between two atoms, okay, there won't be any type of domination of positive and negative charge. Therefore, it is obtained by sharing, it is called, okay. We will see. And particularly in this class, we will see bond formation of single bond between fluorine-fluorine or chlorine-chlorine. That is my choice, right? At the same time, we will see bond formation of double bond. Double bond, the best example for formation of double bond is oxygen. And the bond between nitrogen and nitrogen is treated as triple bond. Let us see now. The first case, we will see single bond. So single bond means what? You have only one sigma bond. That means only one end-on-end overlapping will take place and sigma bond will be formed. So for that, let us take fluorine, whose atomic number is 9 and its electronic configuration is 1s2, 2s2 and 2p5. So what happens? Tell me 2, comma 7 it is. Let it be. Now first case what happened? There are 2 electrons. 1s2. 2s2 how many? 2 electrons. And S has got only one box because one degenerate orbital. Very good. P has got how many degenerate orbitals? 3. So this will be called as Px, this is Py, and this is Pz. 5, you have to fill 5. 1, 2, 3, 4, and 5. So you have got one alone pair of, you have got one alone pair, means leftover pair, alone pair of electron along means where it is in z axis, pz orbital. Same way, let us take one more fluorine, whose number always remain to be 9 only, isn't it? Its number is 9, whose electronic configuration is 1s2, 2s2 and 2p5. So instead of writing for all, I'll write just for P. P has 3 degenerate orbitals, Px, Py and Pz. So let me fill this 5, 1, 2, 3, 4 and 5. So it has got one lone pair of electron. It is same, right? One, because I took the same example, isn't it? One alone pair of electron along where do you find it? Pz orbital, as it is as shown on the top, because I took the same example. Now, how to show this is we have to show the bond formation with Lewis dot structure also. Lewis dot structure. So what did I take? Fluorine. So it is how much I said? 2, comma 7. So I have to represent 7 electrons over here. 1, 2, 3, 4, 5, 6 and 7. Did I take one more fluorine? Yes, I took one more fluorine, isn't it? So I have to represent the same thing in the form of dots. 1, 2, 3, 4, 5, 6 and 7. So now I'll combine these two. 1, 2, 3, 4, 5, 6 and 7. For this also 7. 1, 2, 3, 4, 5, 6 and 7. Come on this side, count 1, 2, 3, 4, 5, 6, 7, 8. It obtained octet configuration. So count this side, 1, 2, 3, 4, 5, 6, 7, 8. Yes, therefore you get F2 molecule. F2 molecule. So what is happening? Can you tell me? Now we are going to see the diagram. The pz orbital, see, one is left over, isn't it, empty? Therefore, this pz orbital of one fluorine will overlap pz orbital of another fluorine. Simple logic. Pz orbital of one fluorine will overlap pz orbital of another fluorine. What type of overlapping will take place? End on end, because it has only one vacancy. So sigma bond can exist independently. It has got nothing to do with pi. If one vacancy is there, you will get sigma. So let me draw. This is what z axis is. Right? This is z axis. So it has got one lone pair of electron here. Z axis. Just now I said no pz. Same way you take one more. Same it is. Z axis with extra electron. This is about one fluorine. This is about another fluorine. This will be z axis. This will, as I already wrote here. Okay, once again, I'll write clearly z axis. Now these two combine because there's only one vacancy, isn't it? Right? You got sigma bond. Did you understand? This is what it means by single bond. If you want double in fluorine, it's not possible. Fluorine chance only one because it's already having 7 electrons as its valency electrons end. Valency electrons means electrons which are found at the end. Very good. Now we will see double bond formation. Double bond, when you say, it is what you know, one sigma and one pi. So you'll get one end on end which gives you sigma, other one is side on which gives you pi. That means they should be what? How many? Two valency element which requires two electrons for its bond formation. So best example is oxygen. Oxygen number is 8. 1s2, 2s2 and 2p4. 8, 2 plus 2, 4 plus 6 plus 4 is 8. So 1s2, I already told you, you have to fill it like this. 2s2, 1 degenerate orbital with 2 electrons. P has got 3 degenerate orbitals and they are written as px, py and pz also. 4, 1, 2, 3, then 4. So it has got two. You can see here two. It has got two alone pair of electrons. Pair of electrons along. Along means what? Where? Where do you find? Along py and pz orbital. So it's here py and pz orbital. So what shall we do? Take another oxygen whose electronic configuration will be same, 1s2, 2s2 and 2p4. Why is it same? You took same oxygen, no? Always it will be same. No need of filling all this, it's understood now, but only thing is with p. Right? P is having 3 degenerate orbitals, px, py and pz. You have to fill this for 1, 2, 3 and 4. So same line. Because you took the same example, isn't it? It has got two alone pair of electrons, along. Where do you find them? One is py and the other one is pz. Here, py and pz. Now what happens, py, see, I am giving you the proper explanation. Py orbital means this one. Py orbital of one oxygen atom overlaps with py orbital of another oxygen atom. That's also simple. Py orbital of one oxygen atom overlaps with py orbital of another oxygen atom. End on end overlapping will take place. First case you will get is always end on end. Once again, see, py orbital of one oxygen atom overlaps with py orbital of another oxygen atom. End on end overlapping takes place and the resultant is sigma bond. Now next what? Same lines. Pz orbital of one oxygen atom overlaps with pz orbital of another oxygen atom. Side-on overlapping takes place and the resultant is pi bond. Py orbital of one oxygen atom overlaps with py orbital of another oxygen atom. Okay. End on end overlapping takes place. End on end means you can even call it as axial overlapping or head on head. Once again, py orbital of one oxygen atom overlaps with py orbital of another oxygen atom. End on end overlapping takes place and the resultant is sigma bond. Same lines you repeat for pz. Pz orbital of one oxygen atom overlaps with pz orbital of another oxygen atom. Side on overlapping will take place and the resultant is pi bond. That's all. So simple. One sigma end on end, one pi is side on. Now I will show the diagram. What did you say? You have two vacancies, no? Just now you took example of oxygen whose atomic number is 8, isn't it? So it was 1s2, 2s2 and 2p4. So what happened here? 4 you have filled for 1, 2, 3, 4. So you were having two chances, py and pz. You took another also. So like this. Now, but tell me, oxygen atomic number is how much? 8. So it is 2 comma 6, isn't it? So these 6 electrons, which are called valency electrons, electrons which are at the end, they should be represented in the form of dots. That is what we called as Lewis dot structure. So I'm writing oxygen with these six. 1, 2, 3, 4, 5, and 6. So I took one more oxygen, isn't it just now? 1, 2, 3, 4, and 5, 6. Now combine these two. First oxygen over here again. 1, 2, 3, 4, 5, 6. This is first one. This one. Plus you took one more, no? 1, 2, 3, 4, 5, 6. This is this one, second one. Count this side how many? 1, 2, 3, 4, 5, 6, 7, 8. Yes, octet configuration. Count this side. 1, 2, 3, 4, 5, 6, 7, 8. Octet configuration. Therefore, what is it you got? O2 molecule. Now we'll draw diagram, right? This was, you see, py, just now I said end on end. So this will be py. So it will be py. One more, two double bond, isn't it? So one more is what? Z. So this will be Z axis, along Z axis, okay? And this is what? Your oxygen atom. So you took one more, isn't it? So the concept remains same. This will be what? Y only. Because just now I explained, py orbital of one oxygen will overlap py only. Py, you see, py, right? And this is Z. Z. Now you combine these two. It's like this, see? This is y-axis, this is y-axis, so you got sigma. Because it is very clearly told, py will overlap py end on end and you'll get sigma. Yes, exactly. Now pz and this pz of second one will overlap side on, side on. See, this is called side on. So you got one sigma and one pi bond. Therefore this is how we explain double bond. So the best example for double bond is what? Oxygen. Now let us see for triple bond. The best example for triple bond will be nitrogen, right? Triple bond. As such, the word is very clear, triple bond, but anyhow you get only one sigma and two pi. Yes, you will get one sigma and two pi bonds. So the best example for this nitrogen, okay? Nitrogen 7, 1s2, 2s2 and 2p, 3 it is 3. So let me draw for the p orbital. P has got 3 degenerate, just now I said px, py and pz. So how many 3? Just 3, 1, 2, 3. So it has got 3 alone pair of electrons. It has got 3 alone pair of electrons along, where do you find them? 3, px, py and pz. So along px, py and pz. Take another nitrogen. You took one more nitrogen whose atomic number is 7. It will remain 7 because atom we are just taking one more, that's all. 1s2, 2s2 and 2p3. Same manner, 3 degenerate orbitals. This will be px, this will be py and this will be pz. You cannot write more. It is 3, isn't it? 3. Now other way, I told you, no, 2 comma 5 it is. The other way, if you count, it is like this: 1 is to 1 k shell, no? So it is 2, and these two should be added, 2 comma 5. Okay, and next, tell me, it has got what? It has got same 3 alone pair of electrons, alone pair of electrons along what? Same px, py and pz, as it is because the example is same. Now explanation, listen. Px first comes what, end on end. So first this will undergo end on end. These two will undergo side on. That's also words. You follow the words so simple. See, you start from here. Px orbital of one nitrogen atom overlaps with. That's all it is. A simple word. See, px orbital of one nitrogen atom overlaps with px orbital of another nitrogen atom. End on end overlapping takes place. Resultant is sigma bond. So one sigma is over. Next, same manner you have to continue for the remaining two. Py orbital of one nitrogen atom overlaps with py orbital of another nitrogen atom. Side-on overlapping takes place and the resultant is pi bond. Same manner, pz orbital of one nitrogen atom overlaps with pz orbital of another nitrogen atom. Side-on overlapping takes place and the resultant is pi bond. So first case you got sigma, these two cases you got pi. So you got one sigma and two pi. Now we will show the same in the form of electron dot formula, form of Lewis dot structure. What do you mean by Lewis dot structure? You are representing these valency electrons around the atom. That is what it means, Lewis dot structures. How many you have? 5. How many you require? 3. So 3 one side. 3, 4 and 5. You took one more nitrogen, isn't it? Same. It is, if you take 2 or 3, it remains same. So what happened? Tell me, these 3 are shared with the remaining 3 from other one. So count on this one, 1, 2, 3, 4, 5, 6, 7, 8, octet. Count this side, 1, 2, 3, 4, 5, 6, 7, 8. Okay, therefore what is that you got? N2 molecule. Or bonds, how many? 3. 1, 2, 3 bonds. So it is called triple bond. Okay. Now, what did I say? This is what px orbital of one nitrogen atom overlaps with what px orbital of another nitrogen atom. You got sigma bond. Next, py orbital of one nitrogen atom overlap with the py orbital of another nitrogen atom and side on overlapping took place and you got pi. Next case is what? Pz orbital of one nitrogen atom overlaps with Pz orbital of another nitrogen atom. Again, side on overlapping will take place and the resultant is pi bond. So you got one sigma and two pi. This is what the structure of nitrogen molecule is.